Hello and welcome to Number Theory for Everyone, the show in which I take some topic that I've learned about studying number theory and present it in a way that I hope is accessible, fun, and potentially even somewhat useful. I'm your host Tony, and you're watching the channel Tony Talks About Math. On this episode of Number Theory for Everyone, I'd like to talk with you about a piece of machinery that we use for various things in mathematics, but I'm going to skip over the usual theoretical development and proving of results, and instead present this in what I think is a very hands-on and practical way. We're going to think about the problem of having some repeated task that you need to accomplish a certain number of times, and you want to have a handle on your progress so far. So imagine, if you will, you're playing a video game and you have to collect items in this game to complete quests or something. On your current quest, you have to collect 55 items. What kind of items are they? I don't know. Maybe gold coins, maybe sandwiches. It really doesn't matter. The point is, out of the 55 that you need, you've so far collected 13. So how far along is that? Well, clearly you're 13/55ths of your way through the quest. But that, to me, is a little bit abstract, just because the numbers are kind of large. I don't have the same feel for 13 out of 55 as I do for something like 2 out of 5. If I have 2 sandwiches down, 3 to go, I know exactly what that feels like. 13 sandwiches down, 42 to go, just seems a little bit more out there. So let's look at the fraction 13/55ths and see if there's a way of getting a simpler handle on it. To do that, we're going to use this piece of mathematical machinery that can take a fraction like this and express approximations of it as simpler fractions. In particular, we're going to make a continued fraction. So we're going to calculate our continued fraction 2 times. The first time, you're going to see all the gory details and why this process works the way it does. And then the second time, I'll show you a shortcut that makes it much more efficient and we can write down a whole lot less stuff. After that, this video has a part 2 in which I'm going to show you a visual that explains geometrically what's happening when we do this process. And then I'm going to show you a much more efficient way of doing these calculations using technology. For now, let's get started and just see what our continued fraction is going to look like. So we start by saying that 13/55ths equals 1 over 55/13ths. I realize that's not a simpler fraction than the one we started with, but bear with me, things are about to get better. 55/13ths has the advantage of being top-heavy. It's an improper fraction, meaning we can do some division and rewrite this as a mixed number. So let's see. 13 divides into 55 4 times. 4 times 13 is 52, and that leaves a remainder of 3. With those numbers, we can rewrite this denominator by saying that our fraction equals 1 over 4 and 3/13ths. 55/13ths is the same as 4 and 3/13ths. So there we have that. Now 3/13ths is certainly a simpler fraction than 13/55ths, but that one's not our goal. We're not there yet. Let us do with 3/13ths the same thing we did with 13/55ths. So we're going to write our fraction again as 1 over 4 plus 1 over 13/3. Again, 13/3 is an improper fraction, so we have a division problem to do. 3 goes into 13 4 times, and 4 times 3 is 12, so that leaves a remainder of 1. Now we can rewrite our fraction again as 1 over 4 plus 1 over 4 and a third. Now we've made this wonderful fraction sandwich and we're basically done. This is what we call a simple continued fraction. All of the numerators in sight are the number 1, which is what we were going for. Now I'm going to show you how this is useful, but first let's condense the notation a bit. And before I do that, I'm going to throw a 0 on the front of it. We always have a whole number in the front, and if our original fraction had been bigger than 1, then it would be something other than 0. But since our initial fraction, 13/55, was smaller than 1, we just start with a 0. And now looking at this expression, we can see the only numbers that really matter are the 0, and the 4, and the other 4, and the 3. Everything else is just plus 1 over, plus 1 over, plus 1 over. That's how a simple continued fraction works. So there's no need to write that part down over and over again, and we have this nice shorthand. It goes like this. We're going to get a pair of square brackets, and we put our whole number part in there first, follow it with a semicolon, and then we fill in the other numbers, which by the way are called partial quotients, and they're all separated by commas. So there you have 4, 4, 3. And that is a nice efficient way of writing our continued fraction for 13/55. Now, like I said, I want to show you 2 ways of doing this calculation. This has been the complicated way where you write down a lot of stuff, and there's currently way too much math on the screen, so let's get rid of most of that. And now I will show you how I like to calculate a continued fraction efficiently. Our quick version of this calculation begins by writing down the larger number, 55, and we're going to say that it equals something times 13 plus something. The first blank is going to be filled in with the quotient of our first division problem we did, and the second blank is the remainder. So as we saw doing our long division, 55 is 4 times 13 plus a remainder of 3. I've highlighted the 4 because it's our first partial quotient. Now to move on to the next step, we take the smaller number 13 and move it back into the big number spot. So there's 13, and then we're going to have the same setup, so we have a blank, and then replacing the 13 will be the remainder from the first step, 3. So 13 equals something times 3 plus some remainder. Now we get to fill in these blanks, and this is the second division problem we did. 13 is 4 times 3 plus a remainder of 1. Now since the remainder isn't yet 0, we're going to do one more step here because we want to see a 0 in the remainder spot. And so we move the 3 and the 1 back, and here's our new setup. And now we can fill in these blanks. 3 equals 3 times 1 with a remainder of 0. Now we have everything we need to write down our continued fraction. Since our original fraction, 13/55, was less than 1, we have 0 for our integer part, and then we just read down the list of partial quotients and fill them in. There's 4 and 4 and 3. Wonderful. This was a lot less to write down than what we did the first time. So let's erase this scratch work, and then we're going to take our nice compact way of writing the continued fraction and move it up here where we can do something with it. First, let's just remember that what this really represents is the fraction 0 plus 1 over 4 plus 1 over 4 plus 1 over 3. Now, I just said we're going to do something with this continued fraction. What can we do with it exactly? Well, we're going to calculate something called convergence, which are actually the point of everything we've been doing. The convergents are the simpler fractions that help us to approximate 13/55. Our process for finding convergence starts like this. We write down a 1 and a 0, just like this, below our continued fraction and just off to the left. These are just here to get the calculation started. It always works the same way. It's always a 1 and a 0. And in part 2 of this video, where I show you a visualization of the process that we've been doing, you'll see a geometric interpretation of what that 1 and 0 really mean. For now, let's just see how the process works. We look at our first partial quotient, the whole number part, 0. And that tells us that our first convergent is going to be that over 1. So 0 over 1 is an approximation of 13/55. It's the closest you can get to 13/55 with a whole number, because 13/55 is closer to 0 than it is to 1. Now, it's not a very close approximation, and certainly not a very encouraging one, so let's move on and see what the next one's going to be. Looking at our next partial quotient, which is 4, we now really start to see how the machinery is going to work. We're going to multiply and then add. So 4 times 0 is 0, and then we add 1 and get 1. Great. Now we do the same thing with denominators. We take our partial quotient 4, multiply, and add. 4 times 1 is 4, add 0, that's still 4, and we have our second convergent, 1/4. So 1/4 is definitely closer to 13/55. 13 out of 52 would be 1/4. 14 out of 56 would be 1/4. So we can see that we're definitely in the right vicinity. Let's do a little better though. Our next convergent is going to use the next partial quotient, the second 4. Again, we'll multiply and then add. So 4 times 1 plus 0 is 4. And then in the denominator spot, 4 times 4 is 16, plus 1 is 17. So our third convergent is 4/17. 4/17 is actually very close to 13/55. And one way to see this is by looking at decimal expansions for these. So 4/17 is about 0.2353, while 13/55 is about 0.2364. As you can see, we're only off by about 1/1000th of a unit, so that's pretty close. Even better than that, 4/17 is, for me at least, a lot more concrete and easy to get a handle on than 13 out of 55. If I've just eaten 4 sandwiches and I have 13 to go, I have a sense of what that maybe feels like. I hope that I'm hungry or that the sandwiches are quite small. Anyway, if we want one more convergent, what else can we get? Well, we have one last partial quotient, so let's see. 3 times 4 is 12, add 1, and that's 13. Then again in the denominators, 3 times 17 is 51, add 4, and that's 55. So our final convergent, 13/55, is simply the number that we started with. We've gone through the whole continued fraction, so we've arrived at our destination. And that all looks great. Now, there's one point I want to make here, which I don't want to spend too much time on, but if you saw my previous number theory for everyone video about the mediant of two fractions, you might find this interesting. That third convergent, 4/17, is the mediant of the fractions 0/1 and 4/16. 4/16 is just 1/4, where we've multiplied the top and bottom by 4. The mediant is calculated this way, so we have 0 plus 4 on top, 1 plus 16 on bottom. In a similar way, this last convergent, 13/55, is the mediant of 1/4 and 12/51, which is just 4/17, where we've multiplied the top and bottom by 3. Calculating the mediant, we have 1 plus 12 over 4 plus 51, and that's 13/55. Great. Now, wrapping up part 1 of this video, let's look at these convergents and see how they relate in a specific way to the continued fraction we've written down. So I'm just going to move the 3 convergents, aside from the last one, over to the left side of the screen. So we have 0 over 1, 1 over 4, and 4 over 17. 0 over 1 is what we would have had if our continued fraction only had one term. And that would, of course, just represent the number 0. 1/4 is what we would have if our continued fraction only had its first 2 terms, 0, 4. And that, of course, is shorthand for 0 plus 1 over 4. The third convergent, 4/17, is what we would have had if our continued fraction only had its first 3 terms, 0, 4, 4. And that is shorthand for 0 plus 1 over 4 plus 1 over 4. And then finally, adding the 4th term, we get the whole thing that we have at the top of the screen. Thank you for watching this video. I look forward to seeing you in part 2, where we visualize some of this and really raise the power of what we're able to do by using technology. But for now, all this calculating has made me hungry. I think it's time to take a break for a sandwich, or maybe 55. If you enjoyed this video, please remember to click like and subscribe. And let me know if you have any comments. You can say something in the comments section. Please consider supporting Tony Talks About Math on Patreon. At this time, I would like to extend continued thanks to my Patreon supporters, including Emily McDonald and Gabby Gabs. Again, thanks for watching, and I'll see you next time.